So yeah, I'm glad you mentioned all the options because I touched upon that, saying it's going to be very hard to come up with, some sort of architecture, even though the 3GPP is working on it with those 7 options. But still, I mean, you made a good point of mentioning that the big issue is the front haul. What do you have in the ground, actually, to connect the radio to the core? I mean, actually, to the baseband unit, or let's put it this way, baseband unit functions, if you decompose the baseband unit, actually. So, question, is this the major issue the mobile networking industry is facing these days, or do you see any other issues when we think about virtualizing as much as we can mobile network functions? Is this the biggest issue we are facing, or do you have any other issues to mention?
Can we talk here?
Yeah, whoever wants to.
Well, I would say there's a few things they have to solve, right? So the migration to virtualization, this is, I would say, there is many more operators that are still looking at it, right? So there are some that make the decision, they're seeing the benefits. I think there is the migration to 5G is worrying them a lot. And if I do the change now, what I take today, is it going to be? Do I have to do another forklift when 5G comes? Since all the operators that you're seeing today are 3G and 4G, right? So one of the questions is, well, whatever I do, will this be usable in 5G, right? So the 5G ready is a big question. Also, I think was mentioned earlier today, in some way the change of the company internally, so you have to have the IT team and the telecom team in some way. This is becoming more like an IT play, if you like, right? So it's no longer telecom versus IT, but it's more telecom and IT, which many of the companies have done that. That is one change that has nothing to do with the technology itself, but has to do with the processes. So there's a few, and then of course you have all the new technology in terms of the new radio components and the new devices coming on board. So it is a number of challenges that have to be attacked at the same time, right? Those are the things that are on the mind, I would say.
Yeah, I may like to add some of these points that you already added. Of course, the IT side, right, the convergence between, I think, previous speakers also talked about the issues with the convergence, both from the vendor side as well as from the operator and the whole industry perspective, right? IT side of the house they are, the chef and many tools. They're very comfortable, but in the telecom side, it's a different sets of tool. So it's a convergence. So IT people have to learn our tools. Networking people have to live with IT, changes that is made in IT. That's one. There are many things we can talk about, challenges, but one of the area that, because it came up, some questions came up today, I'll just touch upon that part, which is service assurance, which is very critical, end-to-end service assurance. It's already difficult today, service assurance, just on the physical alone, because there is so many layers. Just someone talked about IMS. So many, right, from MTAS, S and C and ICSCF, HSS, so many things, and we need to correlate already, along with radio and transport network, to just figure out where is the fault, right? And now the problem is really compounded even further. Now we're bringing the virtualization and SDN. And then I can tell you, I talk to people, and I don't want to name the open source community, that's not fair, but I talk to, because I'm heavily involved, my company and myself, in open source projects. Some of the times I ask them, okay, I need to get certain data from these projects. They literally ask me, what is that? So if you ask me what is that, how will you create, as a software coder, how will you code the system? So even understanding, that's actually nothing wrong with that person. It's understanding of the needs of the telecommunication networks coming from the IT side. And we don't understand their side as well a little bit, right? So that is a challenge, actually. But in the service assurance, the biggest thing is hybrid networks. The networks will stay hybrid for a foreseeable period of time, maybe 10 years. Some of the network functions will never be virtualized. Will stay probably as it is until it dies one day. It has to stay maybe. And so the service assurance has to look at end-to-end. Then the second part is whether it is Kubernetes on the container side, or it is OpenStack, or any other technology that's going to come up. So they need to actually have a better monitoring capabilities, and that's the thing that we need on the top, on the OSS layer, in the orchestration layer. So we can actually close the loop and automate the system and make some action, right? And the traditional service assurance, I was talking about it, right? In 5G, we actually take the new technology as the new technology is becoming available to us. Same thing, today, service assurance, we don't have the analytics. Now the analytics is going to come and play a lots of game within the service assurance. We'll use the service assurance not only for use the analytics to actually figure out the user profile, all of that, user experience. That's one sort of service assurance. But make the network as the best performing networks. That's very key, right? Automated networks. So the analytics will play a major role, both proactive and predictive way in the service assurance area. Just an example, yeah.
Yeah, I mean, Watanabe-san, do you have a...
Yeah, I agree. It's a very good summary, so I don't much to talk.
Do we have a question in the audience? Yes, Michael. Oh, and there will be another one right here.
Just a brief question for Watanabe-san. You're going to deploy 5G in 2020. What is 5G to you in 2020?
What 5G to be used? This is your question, right?
What aspect of 5G? Is it enhanced mobile broadband, or is it more?
Right now, Docomo is focusing on EMBB, we call enhanced mobile broadband. And after that, like URLLC, so like latency and so on. So first, our focus is EMBB, and then we will launch in the 2020 as mobile communication, not like a fixed, like a wireless, like 5G, like Verizon already announced.
Thank you.
So, yeah, I mean, this is a very good point you're making here, because there is a big disconnect between, the 5G thinking here versus the rest of the world, actually, because whether it is Japan, Korea, China, Europe, everybody is aligned on what to do first, because, it's the easiest path. That is moving a little bit higher in frequencies, between the 3 gigahertz all the way to 6 gigahertz. And in fact, in Japan, there is a big testing going on at 4.5 gigahertz. Here in the US, forget about the 3.5 gigahertz because it's CBRS. So in fact, all the bands that the rest of the world is looking at are being occupied for CBRS here. So that's why, you have that kind of question. Fixed wireless access. Well, let's go back to LMDS, back in the old days of the late 90s, and that failed, right, by the way. So why, I'm asking the question, to the US service providers, why do you think that this time around it's going to work? And then the room got kind of quiet, right? So next question.
Okay, thanks. I'm curious what you all think in terms of 2 of the 5G requirements, one being low latency and one being virtualization. And we heard a lot today about micro or picro or nano, containerization or segmentation. And I've heard from at least one big provider that when you have these low latency budgets and you're spending a lot of time going from, component to component, you use a lot of your budget just by being in a virtual world. And is there opportunity to do VNF consolidation or leverage more hardware to make those latency numbers work? Because to me, they seem like they're conflicting requirements.
You're right, but King Yip actually touched upon this issue by saying that in the radio domain, we need to rethink the way we architect the different layers. And on this slide, he actually showed the different options you have. Not all of them, some. Maybe you can...
I can elaborate on a little bit.
Yeah.
So I think there are different aspects, right? So there's an excellent question because, we talk about not just latency, but throughput as well, right? But latency being, very, very hard requirement. The different split can increase the latency tolerance, but most likely in a dense area, you don't want to really do the higher layer split. You want to do more of the comm, so you want to centralize more anyways. So I think a lot of the improvement in the latency is the edge computing aspect, right? So if you can have the service locally and you can terminate, with distributed EPC, so basically the entire path to be as local as possible. So that's more from a grand scheme of things perspective, right? To run all this in an edge data center. And then zooming into individual VNFs, I think there needs to be some optimization of like placing these VNFs maybe on the same system or do some optimization and have some SDN management so you can control that. Even to the extent of they're on the same machine, vSwitch performance, it is also a known bottleneck, right? So if we talk about, each access unit or each, let's say, a fixed wireless customer can get multiple gigs pretty quickly. In a centralized unit, you're going to be talking about 100 gig or something. So the vSwitch technology today actually does not even support that kind of throughput. So there are actually a lot of performance challenges. So from our perspective, and obviously we focus a lot on acceleration and high integration from a silicon, but also we look at kind of on the grand scheme of things, maybe have some more SDN management as opposed to just, doing this is vSwitching, I don't think, a RAN is a case where you can just move the IT practice and put it on telecom because telecom does have a lot more complexity.
Can I add something?
Yes,
to this
please.
question? Okay, we talked about orchestration. So orchestration will play a big role on that. I'll just give an example by deploying a network slice. For example, you take two examples. One is maybe low latency requirement for an enterprise or for a specific vertical industry. The other one is, say, for example, high bandwidth or high intensive devices, number of devices needed, right? So in service orchestration, in the orchestration, we have a couple of layers. One is the service orchestration on the top, what we call business layer, business orchestration. So that's where the need comes in. The next to that is resource orchestration, right? So, or the network layer. They kind of work together to create a network slice because all the business input goes on the service orchestration, and then we have a Tosca template. The network orchestration will expose, hey, this is the type of network I have, to the service orchestration that can pick and choose after that, right? So they work together. And the network orchestration will decompose what's coming from the service orchestration and start deploying. For example, just give an example. If it's a low latency, the resource orchestration can create, okay, you know what, it's a very low latency. I may deploy most of my VNF from the, BBF and EPC and MME, whatever is necessary for this logical network, much closer using the mobile edge computing at the distributed data center where the user plane just terminates there. Or high intensity or more devices, I may take it up to the core. Depending on choices, we can make it. But this virtualization, the SDN, and different layers in orchestration, all of this will create the possibility to do that.
Thank you.
Yeah, and in fact, to give you some numbers about latency, on the lowest I've seen on this planet on 4G is 2 milliseconds at SK Telecom in Korea, but they did a lot of work actually, and it was in a very specific area where they had mobile edge computing, everything you can dream of, beefing up every single function, with lots of them virtualized already because you have lots of VNFs actually in Korea at this point, all the way down to the BBU. And the baseband units actually can communicate to each other and everything. There is resource pooling and everything, so you can go down to 2 milliseconds. But this was just a test. It's not it's not deployed. Now, on a good LTE network these days, you are at 30 milliseconds. Now, if you, you mentioned the case of autonomous driving. We have plenty of them in San Francisco, right? So it's interesting. If you drive around the Moscone Center, you may have noticed a lot of construction. They are remodeling expanding the Moscone Center, and all the way down to the ferry building on Howard Street, actually, and Mission. You go to Salesforce.com. It's a big mess. There is Facebook tower popping up. So you get on a robot car. The robot car is going to be in serious trouble in that area because there is no marking on the street, so the car is lost. So get out the car. because you're in trouble, I can tell. So I've seen, I mean, this is very interesting. We have that movie, every day in the San Francisco Chronicle and on TV about what's going on in the city because it's hilarious. So last week during the Mobile World Congress Americas, there was a lot of stuff going on with big crowds and Waymo from Google, for example, those cars were lost. No, it was very funny. So that's a good example of, I mean, you really need, very good latency to take that under control because somebody, I think, this morning was saying the map, maybe we don't need the map, the real-time map update on the car. You can put in the cloud. Well, in that situation, where is the map update? I know a system who actually figured that out. That's here, from Nokia, but now belonging to BMW, Mercedes-Benz, and Volkswagen, Audi. So in here, the stuff is updated. So if you drive one of these fancy cars, a 2017 version, and you put the autopilot on, the car is going to figure that out in the area. So this is, very interesting. But it all goes, to latency. And that's, we still have a long way to go with latency. And I mean, I know that in Japan, the University of Tokyo had a demo showing how to drive cars remotely, and everything is in the cloud. But that requires extremely low latency. I mean, the demo I saw was below 1 millisecond. It was in a very well protected environment. I mean, are you involved in those demos?
I'm not involved, but I just like to add some comments about the latency issue. So radio access 5G is definitely we achieved very low latency, like less than 1 millisecond. But when we introduce these virtualizations, and then we need to consider we are using generic hardware, but the mainframe I think is the distribution of is the latency is very variance is very small, but all generic hardware can achieve very high low latency. Probably not. So variance is much bigger. So I think it's combination between the virtualized network, core network, and then radio. I should maybe achieve the very low latency. So I think we need to care about implementation for these virtualizations for 5G.
Yeah, and that's the idea of figuring out which function and sub-function in the radio, or between the radio, the baseband unit, and the core, you can shuffle around because each processing step is taking a few microseconds. Some steps actually are more than 100 microseconds. And if you do the math, you get all the way up to 1 millisecond already. So that's a big challenge. And you wanted to add something?
No, I was thinking about something when you mentioned Korea Telecom.
Yes.
Obviously, NTT Docomo and Korea Telecom, they're so advanced. I mean, really. And last, I think this was not this Mobile World Congress. I'm talking the big Mobile World Congress.
Yes.
Barcelona.
Mm-hmm. Yeah.
And so the previous one, Barcelona, we had Korea Telecom, and us, we had VR and AR, augmented reality. Yeah, very low latency.
Yes. Yeah.
It's amazing to see how those things really, some of the use cases, we talked about Uber and all of that in 4G. This mind-boggling, once the network opens it up, what will happen? Very smart people coming up with smart business idea, maybe a billions of dollar company will come out of that when we create that network. So the latency is a big, very critical. Absolutely.
But so NTT Docomo has a demo. So it's a glove with full of sensors. And basically, think about robotic remote surgery. So, you put your hand in the glove and, you do some motion like taking something. And then, on the other side, there'll be the robot replicating what you are actually doing. And it's it's amazing. It was a very amazing demo I saw in May at the 5G Tokyo Best Summit. So, that's where we are going.